following on with complex numbers, we're going to solve this cubic equation. The first thing to do is to try get one of the solutions, some sort of quick inspection, and we can see that these coefficients, if you 2 plus 7 minus 5 minus 4, that's equal to 0. So if the coefficients sum to 0, then z equals 1 is a solution. Alright, you can see that, you just plug it in, because each of the z parts are just 1, so then it's just a matter of summing the coefficients. So as I said, they add up to 0, so that's a solution. And if z equals 1 is a solution, that means we can factor our cubic into z equals 1, z minus 1, into some quadratic equal to 0. So we need to get a 2z cubed term, so the only way we can do that is with a 2z squared, because you can only get a z cubed by multiplying a z by z squared in this setup anyway. And we've only got one coefficient term here, the minus 4, so our coefficient term at the end of this, no, our constant term at the end of this quadratic needs to be 4. 4 times minus 1 gives us minus 4. Now we need a term in the middle that gets us our middle term. So let's just look at the z squared. We've got minus 2z squared already, so we need to have minus 3z squared, and the way we do that is with a minus 3z. Multiplying that here gives us minus 3z. Right. And now just to check, does this give us 7z? Well, here we get 3z and 4z, so there we go. So one of our solutions is z plus 1. The other possible outcome we have is that 2z squared minus 3z plus 4 is equal to 0. And we can solve that using our quadratic formula. So z is equal to minus b, so that's 3, plus or minus the square root of b squared, so minus 3 squared is 9, minus 4a, which is 2, c, which is 4, and that's all divided by 2a, which is 4. This is equal to 3/4 plus or minus the square root of minus 23 over 4. That's equal to 3/4 plus or minus root 23 over 4i, where I is equal to the square root of minus 1. Right, this leads us on to another important note. Sometimes in these questions, solving quartics or cubics, you will be given one of the complex roots, but the important part about complex roots is they always come in conjugate pairs, alright? And what does that mean? Well, if you've got a complex number z equal to a plus bi, where a and b are real numbers, then z conjugate is equal to a minus bi. So what I'm saying about the complex conjugate pairs is that if z equals a plus bi is a solution to the equation, then so is z conjugate, which is a minus bi. Okay, so when you're given one complex root, you're given another root for free. So that's something helpful to remember. That's it for this video. Complex numbers, we'll look more at them in the next video on A-level further maths. So I hope you enjoyed this video. If you have got something in particular you want to know, let me know in the comments. But for now, please like and subscribe, and I hope to see you in the next one.